Hey everyone! Today, we're diving into some mind-blowing research that connects the mysteries of space with cutting-edge experiments here on Earth. Researchers at CERN have made a groundbreaking leap by replicating the jets of matter and antimatter that stream out of black holes and neutron stars. Let's explore how they did it and why it's such a big deal. Welcome to Trendstorm. Chapter 1: The Big Idea. At CERN's HiRadMat facility, the Fireball collaboration has successfully created a high-density electron-positron plasma beam. This beam mimics the astrophysical jets we see shooting out of black holes, providing us with new insights into these enigmatic space phenomena. Chapter 2: Why this matters. Dive into the heart of an active galaxy, and you'll find a supermassive black hole devouring material from its surroundings. In about 1 out of 10 such galaxies, these black holes also emit jets of matter at nearly the speed of light. These jets are thought to contain a plasma of electrons and positrons, which shapes the dynamics and energy around the black hole. However, understanding this process has been tough because it's hard to measure with telescopes and complex to simulate with computers. Chapter 3: The Experiment. To tackle this challenge, Charles Arrowsmith and his team at CERN's HiRadMat facility conducted a groundbreaking experiment. They extracted a massive 300 billion protons from CERN's super-proton synchrotron and fired them onto a target of graphite and tantalum. This collision generated a cascade of particle interactions, producing huge numbers of electron-positron pairs. The team measured the resulting relativistic electron-positron beam and found that the number of pairs exceeded 10 trillion, 10 to 100 times more than previously achieved. This is significant because it's the first time the number needed to sustain a plasma state has been exceeded in a laboratory setting. Chapter 4: Why it's important. Arrowsmith points out that while computer simulations of these plasmas and jets are useful, they've never been tested in the lab. Laboratory experiments are crucial to validate these simulations because simplifications in the calculations can sometimes lead to vastly different outcomes. This experiment is just the beginning. The Fireball collaboration plans to conduct more experiments at HiRadMat, including observing how these powerful jets interact with a meter-long plasma and generate magnetic fields that accelerate particles in the jets, one of the greatest puzzles in high-energy astrophysics. Chapter 5: Broader Implications. Gianluca Gregori, co-author of the study, highlights that these experiments are designed to reproduce in the lab the microphysics of astrophysical phenomena like black hole jets. While astronomical observations and simulations provide valuable insights, they can't probe the microphysics as effectively. These lab experiments serve as a crucial bridge between observations and simulations. The Fireball experiments are a thrilling addition to HiRadMat's portfolio, and we can't wait to see what discoveries come next. This research not only advances our understanding of cosmic events but also showcases the incredible capabilities of CERN's accelerator complex. Source: CERN. Conseil européen pour la recherche nucléaire. If you found this video fascinating, don't forget to like, comment, and subscribe. Share your thoughts on how you think this technology could change our understanding of the universe. Thanks for watching, and see you in the next video.